Hello boys and girls, welcome to another episode of FoulkesBrau. Today on the bench we've got this Lyman digital power loading system that seems to be giving problems. So let's not waste any time, let's get on the bench and let's see what it is doing and we can take it from there. Right, so here we have our power loading system, or powder loading system. The way I understand it, there's a flask that will go on top of this thing. It's a automatic weighing system for gunpowder for those guys that make or reload their own cartridges. We have the power here, so I'm just going to plug it in and we're going to see what it's going to do. There we go. So it beeps, and that is the end of it. So we press and hold. Nothing seems to be happening. Okay, don't know what this does. Not sure. Okay, so it's dead. Let's see on the back. Funny enough, you've got a slide switch here for 120 volt, 110, 120 volt, or 220 to 40 volt, 60 hertz or 50 hertz. But interestingly enough, it comes with an AC adapter that is 230 volt, 50 hertz, 15 volt AC, 310 milliamp output, or 4.65 VA. So very strange that you have something like this. Anyway, not much to this. There's a couple of screws up here, 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 there, and there. So let's just take it apart quickly and we'll come back to it on the bench. Right, we've taken the cover off. As we can see, there's not really much to this circuitry. There's a board here where our power comes in. There's a little board down here, and then there's the front end board with our LCD and keypad. We can see our AC comes in here. We've got two full wave bridge rectifiers there, smoothing capacitors, inductor, LM317 regulator, some more filtering, and we've got an IC down there, a little pot down in there for whatever calibration or offsets they need to set, but they have scrubbed the markings of that chip. So that is some little microprocessor of sorts. And again, we have another little microprocessor down here that they've scrubbed. So we know that the LCD doesn't switch on, or the machine doesn't switch on, it beeps. So let's just show you this. Put the power in. It beeps and it switches straight off. So what we can do is we should check our voltage rails. I don't see any fuses on this thing. So let's try and put our multimeter in the shot here. I'll just zoom out a little bit so we can have the multimeter here. What I'm going to do is I'm going to check the voltage rails. So I've switched the multimeter to voltage DC, and looking at the marking on the bridge rectifier, it looks like the right hand side will be our negative rail. So if we measure our DC voltage in here, if I actually get it in and get my hands out the way, 22, so it's the other way around, so 22 volts. We'll measure the other one. .22 volts. Let's just move that out the way. The next thing to do is obviously to measure the voltage regulators. Well, we've got 11.4 volts there on the output of that regulator. So LM317 adjustable regulator. I'm pretty convinced our voltage rails are fine. We have another bunch of voltage regulators down there. I can measure them for you. So let's see, what are we getting out of here? Okay, my probes are swapped, so we got 13 volts on the output, 22 on the in. And the other leg should be going to ground. I've got the voltage regulator, so it's probably another adjustable regulator. On that side, okay, it's a little bit difficult to get in. I'm convinced our voltage regulators are working fine. If we look at the back of our touchpad, you can see it's some sort of a resistive or capacitive divider. Let us see. I'm pressing these and nothing's happening. So I'm just going to pull the power out. We'll unplug the keypad. And if we look at our on-off button, it's that one there. What we can see is the outer shell comes all the way around. It comes to this pin up here. So pin 1 or pin 6, whichever way you're working up, because there's 6 lines. The inner shell goes to that one's outer, and goes all the way around to that pin there. So let us put the power back. And what we're going to do, I'm just going to put that like that. We'll move it out the way so we can get our multimeter in. Still voltage DC. I'm just going to measure the power to each of those pins down there. So let's get a negative rail. We've got 5 volts on the first pin and 5 volts on the second pin. So what can we deduce? We're pressing the switch is not making. Let us do something else. I'm going to put the multimeter to current. And we're going to just do this. And voila. Our device has started up. So what we do have is we have a faulty keypad. Let's see if we can, it says press to hold to switch it off, so let's press and hold. I switched it back on, so we'll do that again. Yeah, Yes, no. Okay, so how do I switch it off? Press and hold. And there we've switched it off. So we'll just do that once more and we'll switch it back on. And there we've managed to switch it on. So our keypad for this machine is faulty. There is our keypad. So let's set up another shot and we'll come and have a closer look at this. So I've zoomed all the way in, and what you can see on this keypad is here where the mechanical reinforcement ends. If you could see there from the side, it's even better shot. If I bend it, we can see that track is actually broken. So that is why our keypad is not working. Yeah, you can see a bit better when I was talking about the tracks to know which pin to bend or to short. Clearly, one of my neighbors is on his weekend warrior mode. So we can see that track runs all the way around. It comes to the outer shell of that one. It goes to the outer shell of that one. The inner shell of that one runs to the outer shell and runs all the way around to pin 1. And if we turn it around, we can see that is the one we're interested in, the on-off button, which is that one. So we shorted pins 1, pin 6, we managed to switch it on. So let me zoom out here. The chances of us being able to buy this keypad as a replacement part are virtually zero. I don't think we're going to be able to get that. Unfortunately, this is quite a expensive bit of kit, and what the guys use it for is reloading their cartridges for their hunting rifles and stuff. So it's quite an accurate little device, and I believe it costs about 6,000 or 7,000 South African rands, which is a lot of money. But we can make a plan and fix this. If we trace this matrix out at the back, what we can do is we can use some of this Vera board. We can just put some tactile switches on the back that will mask up with where these switches are. We can put a bit of ribbon cable, computer ribbon cable, not this horrible stuff, because this does break, it flexes and contracts over time, vibration, it kills it. So if we build something at the back of it and it can fit in the indent, let me show you in the little cutout in here. So our Vera board will be sitting behind this, bit flush with the switches. Our keypad will go on top, and what we can do is just drill some little holes in there so that the switches line up with here and push up through there. Then I'm pretty sure we can repair this and save it from the dumpster dive. The Vera board is not expensive. The tactile switches we will use probably, I don't know, 3 or 4 rand a switch. and I think that's well worth the repair. A 12, 16, 20 rand versus throwing this away, I think is well worth it. So there we go. Not a really exciting repair. Important thing is we switch it on, we notice there's no power, we checked our voltage rails, well there's nothing blowing, no smoke coming out. We checked we're getting power on our secondary side of our full bridge rectifier. We checked our voltage regulators and they're happy. We checked that we have voltage on the pin matrix or the keypad matrix, which we do. We're pressing the pins, nothing's changing. But if we short the pins out to do whatever we need, it does change. Then we have a closer look at the keypad. We know, well, from a close inspection, we can see it was mechanically damaged. But even if we're half blind and we couldn't see that, what we could have done is put our multimeter prongs in here to match the pins and press the button and see whether the resistance changes, which it doesn't. So there you go, faulty keypad. It's set up for the end shot. Well, that brings us to the end of another repair video. Not very exciting, but well worth saving. Expensive little bit of kit for those hunting aficionados. Not something I do, but it is something that should be nice to repair because it involves a bit of mechanical work. So yeah, it should be rather interesting. What I will do is I will order the tactile switches. We'll build a PC board together. I will get a colleague to drill out the little holes where the keypad should go, so that the new tactile switches will fit through. And yeah, we'll take it from there. Anyway, as always, I hope you found this video enjoyable. I haven't forgotten about the craft beer. It is still going. We will make a follow-up video on that soon enough. And as always, take care, be safe, we'll catch you in the next one. Cheers.